Let's jump right into this explainer. Today, we're diving deep into how artificial intelligence is literally compressing time to revolutionize decision-making. We'll use Palantir's Maven system as our core example here, and we're going to break down how this tech actually works on the battlefield, the massive ethical dilemmas it kicks up, and, get this, how these exact same principles are being used right now to build a God's eye view of your very own living room.
Okay, we've killed more people on Microsoft Office than you would ever imagine. That is a seriously jarring quote from a military officer. For years, the frankly outdated reality of managing global conflicts meant tracking targets in basic Excel spreadsheets. Seriously, analysts were using PowerPoint to map out network connections and standard Google Earth to zoom around. Just imagine being a modern commander with access to the most sophisticated sensors on the planet, but you're heading into battle with the exact same software suite you use to plan a Tuesday budget meeting. Crazy, right?
And that massive bottleneck is exactly what Maven was built to solve. The old way? A room full of analysts, painfully and manually cross-referencing data across totally disconnected programs. Maven completely transforms that reality into a single AI-driven interface. It's basically Google Earth for warfare, but with an AI constantly whispering in your ear, automatically telling you exactly what you're looking at by instantly fusing all available intelligence. A real game changer.
To really wrap your head around the scale of this upgrade, let's look at the first 12 hours of Operation Epic Fury in the Iran War. The U.S. struck nearly 900 targets, 900, in just 12 hours. That is a staggering, almost incomprehensible feat of speed, and it was entirely coordinated by software, representing a massive, massive jump over historical capabilities.
So the core framework making this blistering speed possible is something called the UODA loop: observe, orient, decide, and act. Now, this is a classic military concept, but Maven's AI compresses this cycle so drastically that adversaries literally can't plan or catch up. They are kept permanently trapped in react mode. Let's quickly walk through exactly how Maven executes each of these 4 steps.
All right, step 1, observe and fusing global surveillance data.
Obviously, a system is only as good as the data it can see, which requires an unimaginably vast array of global surveillance. The crucial point here is the sheer volume and variety of modalities being fused together. You've got synthetic aperture radar, which fires literal radar pulses, making it way better than standard imagery because it sees straight through thick clouds and pitch darkness at a 25-centimeter resolution. Then you have wide-area motion imagery, like the Gorgon Stare system. This thing stitches 368 cameras into a 1.8 gigapixel live feed. It's essentially persistent, rewindable surveillance of an entire city from 25,000 feet up. If something happens, analysts can literally just hit rewind on the footage to see exactly where a vehicle came from. But what happens if an adversary just jams the GPS signals, which, is highly common in conflict zones? Well, these drones keep observing anyway. They use visual positioning systems. By actively matching their live onboard camera feeds against pre-built 3D terrain models, like Vantor's Raptor system, the drone knows exactly where it is without needing a single GPS satellite to guide it.
Okay, this next part is wild. What if a shadow fleet paints over its ship names and turns off its maritime transponders to completely hide? Well, Maven can still observe them using advertising intelligence. If even one single crew member on that hidden ship is carrying a personal mobile device and playing a game, like Candy Crush, the ad network data pings their geolocation. The system then uses that simple ad tech ping to pinpoint the exact location of the entire vessel. Absolutely incredible.
Moving on to steps 2 and 3. Orient and decide, with AI at the helm.
Once we've observed everything, Maven handles the orientation and decision-making using what is essentially an AI-powered Kanban board. Instead of analysts manually comparing drone video to satellite photos, Maven automatically gives a target a stable identifier, managing it almost like a ticket in a workflow. It knows that a truck seen on a satellite is the exact same truck seen on a drone feed 10 minutes later. Then it actively decides. The system generates instant recommendations, picking the optimal military asset to deploy based on complex variables like fuel, proximity, and payload. And crucially, recent reporting indicates that the brain powering a lot of this orientation and decision-making is actually Anthropic's Claude 3.5 Sonnet. It handles natural language intelligence queries. This means operators can ask the system complex questions about targets and operational data, and it evaluates all that fused information in real time.
Now, this partnership highlighted a significant tension. Anthropic enforced strict rules. Their tech cannot be used for fully autonomous weapon systems
or mass domestic surveillance. In response to these restrictions, the Trump administration labeled Anthropic a supply chain risk. And regardless of where you stand on that, it perfectly demonstrates the ongoing, very real debate over who actually dictates how private tech is ultimately deployed by governments.
Finally, step 4, act, the speed of execution. Assuming the rules of engagement are met, a human operator clicks approve, and we close the kill chain. The terrifying efficiency of a compressed UODA loop becomes super clear in practice. Take the March 13th raid on Carr Island. Maven pre-computed and parallel processed the intelligence, allowing the military to strike 90 simultaneous naval and military targets. We're talking mine storage, missile bunkers, air defenses, all at the exact same time, while deliberately leaving the adjacent oil infrastructure completely untouched. Software orchestration is what makes that level of precision possible.
But let's look at the ethical cost of speed. What happens when we compress the loop too far?
It's an incredible technological achievement, for sure. But we have to slow down and ask, when a system processes thousands of targets every single day, what gets missed? This brings us to a really heavy, provocative dilemma. Right now, there is a human in the loop for every strike. But as the system scales up and speed becomes the ultimate advantage, true, meaningful human oversight becomes physically impossible. If the AI misclassifies a target at that incredible speed, who is liable? We can actually relate this directly to the whole debate around self-driving cars. Look, eventually, autonomous driving will be statistically safer than human driving. But at a large enough scale, deadly anomalies and incorrect decisions will inevitably occur. When an AI makes a lethal mistake that a human just wouldn't have made, pointing to a statistical defense offers very, very little comfort.
So we're entering this incredibly complex web of liability. Say an automated system strikes a civilian structure. Why did it happen? Was the AI model maker, like Anthropic, at fault? Was the commercial satellite imagery flawed? Or what if the underlying map data simply mislabeled a school as a warehouse? Or does the blame fall entirely on the overwhelmed human operator who clicked approve on a target they literally didn't have time to properly vet? Right now, we're navigating this chaotic web with absolutely no clear answers.
All right, let's pivot to civilian and home applications, bringing the UODA loop right to your living room.
What's fascinating is that this exact same technology, this fusion layer, is rapidly bleeding into commercial, civilian, and even personal applications. The underlying OODA framework is universally adaptable. The exact same Palantir technology that fuses battlefield data is currently optimizing logistics for the World Food Program, it's catching complex money laundering for global banks, and it's managing massive data systems for the UK's National Health Service. The same logic applies whether you're tracking a missile launcher or an Airbus supply chain bottleneck.
And it is trickling down to the consumer level right now. You can literally build your own localized situational awareness loop at home. By combining public satellite data, open-source intelligence, and your own smart home cameras, you can create a personal fusion layer. Think about it. You could use an AI like Meta segment to identify specific objects on your security feed, and then use Gemini or Claude to infer the context. It could automatically decide if a visitor is just an expected delivery or a genuine anomaly, without relying on basic, centralized alert systems.
So, as these powerful AI fusion layers shift from classified military servers to publicly accessible commercial tools, we're left with a profound final thought. The technology to radically compress the time between observing data and taking action, it's already here. The question isn't if it will change society, but how. How will you use the OODA loop to manage the data of your own world? Are you ready to build a God's eye view of your own life? Thanks so much for joining me on this explainer. Keep asking those big questions, and I'll catch you on the next one.